lesson, we're going to learn about the different activation modes. These are quite important because they define the behavior that your rigid body objects will follow upon collision. So we're going to learn about this somewhat important feature in this lesson using the provided scene, which is 04_bowling_example.fbx. Now, once you have that file pulled up, we can proceed and start adding rigid body properties to get a simulation going. So to do that, once again, we'll need to go to the asset browser, down to physical properties, and now we can take the rigid body property and apply it to the objects. Let's start from left to right. So let's apply the first one to the bowling ball here. So release your mouse over the bowling ball, and now a new physical property will be added and it'll be linked to the bowling ball. Now let's reproduce or recreate the step. This time we'll apply it to the platform over here. Now it's quite an interesting setup that I have here because I have a plane that's acting as the reflective surface, so we can see reflections in here in real time. And we kind of have basically what is a cube, and this cube is acting as the alleyway or the platform here. Now what object would we use for rigid body dynamics? Whenever working with rigid body dynamics, a useful tip is to try and ensure your rigid body objects have thickness to them. You can use thin or flat objects like the particular reflective surface here. You can definitely use those and your simulation will work, but it's not the best method, or it's not the best type of object to use. It's always best to use an object that has thickness to it to ensure best performance and also maximum accuracy. So in this case, we won't use the reflective surface for collisions, rather we'll use the alleyway or the alley object here. So with that said, grab another rigid body property, drag and drop it over onto the alley cube. And now finally, we have to deal with the pins here. Now, conventionally you would take a new rigid body node or rigid body property and add it to every single one of these pins here, but a better approach is to actually share a single rigid body property among multiple objects. That's one of the cool features in the Motion Builder rigid body system, and that's basically using multiple objects with the same rigid body property. That way they share the same properties and they'll behave the same as well. To basically create such an assignment, you need to have the type of object selected. So select all the pins that you want to share the same property, and now grab the rigid body property and drag and drop it over onto the selection. If you take a look at the physical properties now, we have added only a single new rigid body node in here, which is going to basically be tied down to all of these pins. You can confirm this by going to the scene level, and here all the pins are using the same rigid body node or rigid body property. This is pretty cool because we don't need to keep adding new rigid body properties for every one of these pins. We can take all the pins, select them in one go, and add the same rigid property to all of them, and this makes things easy to maintain in the long run. Now we're just about ready to add another solver or the solver to the scene to get things going, but before we do that, a good practice to get into is to rename your physical properties here. Right now they're not very descriptive as to what rigid body they're representing. So we already know the order in which we attach them, so let's go ahead and rename these to something more distinguishable. Let's grab the first one, which is for the bowling ball, right click, and let's rename it like so. Unfortunately, my rename option is getting clipped out of the viewing area, but it's in this right click context menu. Go ahead and select rename, and let's call this RB_bowling ball. Let's move on to the next RB or rigid body object, which is the alleyway. So right click, rename, and let's call it RB_alley. And the last one was for the pins, so take it, right click rename, and call it RB_pins. There we go. Now these names are a little bit more descriptive, and we know which properties are designed or defined for which objects. Now with that done, grab the physics solver from the asset browser and drag and drop it onto an empty space, and there we go. Now we can test the results, so turn it on, and let's check on live. Alright. So we kind of have an interesting result here. The reflective surface is not parented to the alleyway, so it's not moving with it. That's not too big a deal. What I want to concentrate on right now is ensuring that this alleyway doesn't fall. Whenever you go bowling, your alleyway never falls down because it's basically an object that's stuck in space, if you think about it like that. Essentially what we want to do is we want to make sure that forces like gravity do not pull the alleyway down. And the way we can do that is by changing the activation mode. The activation mode defines how your rigid body will behave based on forces and collisions. So the way you can tweak this is by going to the physical properties for the desired object. So we can go to RB_alley and make tweaks to the activation. It's interesting to note that we cannot change the activation property no matter how hard we try now. We can change other properties or other sliders or fields like friction, and bounce, but we can't change the activation type. The reason for this is because our solver is on. If your solver is on, you cannot change the activation mode. So if you want to change your activation, go back to the solvers, turn it off. First, let me go ahead and turn off live, reset to start so I retain or go back to my original state, and now turn it off. That way we'll preserve the start state. And now we can go back to the rigid body alley. We can finally alter the activation properties, and we can change this to something like passive. Whenever your activation is set to passive, your object will not be able to move or will not be moved by collisions and forces, but it'll still be susceptible or it'll still have other objects collide with it, which is exactly what we want in this case. We don't want the alleyway to fall. We want it to be steady, but we also want objects to be able to bounce off of it or collide with it. In such a situation, the passive option is the best. Anytime you want objects to act as a barrier or something that cannot be moved but can be still collided with, you want to use your activation mode as passive. Now with that, let's go back to the physics solver, turn it on, turn on live, and now you can see the alleyway does not fall down, which is a little bit more of a predictable or more realistic behavior. You can definitely see that the pins can collide with it like so. Now with that, let's deal with the pins here. The reason why the pills are falling is because gravity is pulling them down, and then they're colliding with the surface, and then they're basically moving about like that. We want to preserve their state until the bowling ball hits them, and then they can be moved around. So in such a situation, you want to make sure your active mode is set to the other option, which is active at collision. Let's go ahead and turn off live, reset to start, and set our solver off. And let's go to the RB, or the physical properties for the pins. Here, take the activation and set it to active at collision. Active at collision is very unique in that your objects are going to be active, but they're only going to be active whenever something hits them. Until then, they'll remain passive, and this way we can preserve the state of the bowling pins till the bowling ball hits them. So with that, set the activation mode for your pins to active at collision, go back to the physics solver, turn it on, turn on live, and now only the bowling pin falls, and only the bowling ball falls rather, and the pins are preserved in a standing state. Now we can simply push the bowling ball towards the pin here. All we have to do is go to the solver. Let me resize this. And we just need to turn on selection adds a force. When you check it on, when you click on the bowling ball here, you'll be able to propel it forward in space. And there we go. We have a little bowling scenario set up here. Click on the ball to basically launch it. So this is basically activation in a nutshell. We have three options, which are basically active, active at collision, and passive. And these greatly define the kind of collisions you'll get. Passive means your object cannot be propelled by other rigid bodies or cannot be moved, just like the alleyway. Active, basically what we've been working with, means your object can be moved by forces and collisions. And active at collision means that collisions or the object will only move whenever an object has struck it. Until then, it'll remain passive, or it'll remain in a state of static motion.